Hi, I'm Andrew Plotkin. Welcome to the first streamed presentation of NarraScope 2020. Now, I'm not going to do the whole Welcome to NarraScope speech yet. That is going to happen tomorrow at this time, noon Eastern Time. We'll do the opening ceremonies tomorrow, the fireworks, the robot parade. We'll introduce our keynote speaker, Xalavier Nelson Jr. Tune in tomorrow for that stuff. Today is the workshop day for NarraScope, and we will be streaming two presentations on interactive fiction tools. Right now, allow me to introduce Graham Nelson. Graham Nelson is the author and maintainer of the Inform 7 design system for interactive fiction, which is based on natural language. He also created Inform 6 as well as Informs 5, 4, 3, 2, and 1. He is a fellow of St. Anne's College at the University of Oxford, and he will be talking today about the current state of Inform. So, you're on.
Okay, well, thank you very much. As has been said, I'm the author of software called Inform for creating interactive narratives, and this is a programming language based on natural language. It's been widely used by writers and educators since the early 2000s. I'm speaking to you from the University of Oxford. This is our first term without having students in residence since the Great Plague of 1665, I'm told. What we've done instead is to hold over 40,000 Microsoft Teams meetings, but we're not allowed to use Zoom. So this is a special treat for me, and I'm not very familiar with the controls, but I hope I'm coming through okay, and my text and slides will all be going online. Well, let me start with some more recent history than 1665. Let me talk about Boston in the year 2019, which now seems like a very long time in the past. And if I can start in the start of American TV, previously on NarraScope. So this was NarraScope 1 last year, and I'm not sure if we write these with Roman numerals like Super Bowls, but I'm going to call it NarraScope 1. I promised to complete publication of the Inform source code by, quotes, autumn 2019. Autumn is a word with a good deal of give in it, but I think we can all agree that it is now 2020. And that, like all programmers since the beginning of time, I underestimated what was involved. Something else that I talked about at NarraScope 1 was literate programming, which is a method for writing code which blurs the difference between a program as a functional thing and a program as a text for humans to read. Literate programming is an idea that has influenced many aspects of Inform, and it's led people, for example, to publish whole Inform programs as books. Part of the appeal of literate programming is that it helps us to make a kind of art object out of code. And there are a few digital artists who've been enthusiastically doing that sort of thing. Here's a rather fun one. This is something called Wenyan Lang, which is by Lingdong Huang. The idea of this is that it's a programming language in classical Chinese. What you're looking at here is a Wenyan Lang program to draw the Mandelbrot set. And the writing beside the output is actually the program. Just imagine how excited archaeologists would be if they found this page in a jar in the desert somewhere. But the original purpose of literate programming is not actually to create art for its own sake. It's to explain and justify a program and to give a description of it which has real power to justify its correctness and to record its design decisions. And this is what I'm currently trying to do with the complete Inform source code. So in this process, people have been giving me a great deal of encouragement, both direct and tacit. I currently have the unusual combination on GitHub of 193 followers and 0 public repositories. So following me cannot be a very gratifying experience for those 193 people. But I would just like to say it does really mean something to me. And I feel the presence of those watchers every time I'm checking code in. And I do feel it as a kind of patient encouragement. And it's really nice that somebody cares. So for those followers, and even for the kind people who email me to say that the responsible thing would be for me to publish weekly bulletins on how I'm getting on, I really am sorry to be running late. But I do feel I've learned a lot in the year since NarraScope 1, which was itself an important event for me. And well, that's the previously part. So now I'm going to start this talk again with a proper title. So I'm going to talk about what it means to explain a program, how I'm approaching that problem in the case of Inform, and how far I've actually got with doing it. So what do I mean by engagement? Well, at one level, software is a kind of affordance. It's a lever that you pull when you want something. But at another level, it's a social event. It's a kind of gathering. And that can be true even with surprisingly basic tools. So for example, if I want to unzip a zip file at the command line, I might use a Unix command, and then I might look up the man page for it. And in the process of doing that, a little social tide is pulling at me. I look at the man page for the unzip command, and suddenly I'm part of a whole tradition of pioneering developers whose tools all interlock in a particular way. I start to recognize patterns there, and then I start to imitate them. Engagement, I think, is interesting because it involves groups of people making collective choices. So persuading people to engage is a lot of what we do as teachers, and I'm conscious that today is a forum for educators as well as others. Engagement is also interesting because it's a two-way process. It's not just that people choose software to fit their needs, they also choose their needs to fit their software. And compelling software can just change the way you think about what you're doing and give you other ideas about what to do. So I want to talk about engagement, and I'm going to borrow from a cliche of user interface design, which is the idea of progressive discovery. So that's the idea that a user interface like this one, this is the user interface of a Boeing 747, is a bit too much for beginners. Maybe the way it should really work is that the first time you sit down, there would just be the throttle and the on-off switch. And then after a few hours of flying time, the flap controls would appear and so on. Gradually, you'd learn more and more. It's very hard to do that well, and that often fails, of course. But the idea is nevertheless a good one. And we also use it in documentation. So a lot of books on programming languages have a chapter 1, which tells you how everything is really very simple. And then those are actually, to some extent, white lies. And by chapter 8, the reader is ready for the actual truth. So I think a similar process applies to the way people befriend software, if I can put it that way, the way people make software a part of their lives. And there's really a spectrum of engagement here, but I'm going to divide this idea of progressive engagement into 5 stages. Now, as I mentioned, a lot of people here are working on interactive fiction in education. And when we're teaching students about creativity software, so Twine or Inform or something like that, it's not our job as teachers to be certification coaches, to be instructors who give students every last detail. It's not really about the students turning into expert users. It's much more about removing the pain points for them, about letting them be creative, about letting them work as freely as possible. The best software in that sense is kind of invisible, even though it's always there, like one of the butlers in Downton Abbey. So from that point of view, only the first 2 or 3 rungs on this kind of ladder of engagement may be relevant to education. But I hope you'll bear with me as I climb all the way down or all the way up this ladder just the same. So let me start with the first of these, discovery. Now, each stage in this ladder, I think, comes with its own materials which are needed to support engagement at that level. So what is discovery? Well, how do people decide, for example, what language to use when they need to write a program? How do people discover software in general? Sometimes employers or colleges choose for them. Sometimes people join an existing community, and they may even go looking for that community. They may ask, what are the cool kids using these days? Sometimes they follow popularity, which is quite a good proxy for trying to find out what is well maintained. But there is also a role to be played by advocacy, which is when people are going out and trying to attract users. Now, advocacy can be anything from quirky blog posts and podcasts to recommendations in person. But I think in its purest form, it comes down to the kind of elevator pitch for software. How do you sum up software in a couple of sentences? Here are some examples. These are strap lines that you can find on the home pages of some recent programming languages. I've highlighted in green here some of the bigger claims made in adjectives, but you can see what they're trying to say about themselves. Rust, for example, is saying a language empowering everyone to build reliable and efficient software, and so on. Now, there are shades of meaning among these sample strap lines. You can probably tell that Swift cares a bit more about performance than it does about thread safety and so on. But basically, these are all the same pitch. And these four languages are basically four actors all auditioning for the same part. So in that sense, this advocacy isn't very effective because, well, it already assumes that you want the thing that the program does. So if we look at pitches for more unusual programming languages, here's a wider range. Now we see that these pitches are starting to differ from each other. These languages are trying to differentiate themselves on different axes, as it were. The problem is no longer pick me, I'm better. It's now pick me, I'm a whole new thing. I particularly like the definition of AppleScript, a scripting language created by Apple, by the way. So I think here we see advocacy counting a bit more. But if we're going to advocate for a program, we have to decide what it is we think is good about it. And that leads directly to the question of, well, what would be good? What virtues are we looking for? And if you'll forgive a perhaps slightly surprising digression at this point, I think the comparison between how people choose a programming language and how science develops is quite interesting. So consider this book. This is a textbook that was published in 1550. Now, people who were working astronomers, insofar as that was a profession in 1550, were perfectly able to use this book to get accurate results about where all of the planets appear in the night sky. And even though it places the Earth at the center of the universe, the theory that they had worked fine. A couple of generations later, though, and people are now using an entirely different theory, doing their calculations entirely differently, but getting roughly the same answers at roughly the same level of accuracy. And it wasn't that many people actually converted from one theory to another. It was more that new people came along and they were taught different ideas. Well, I mean, I think there are obvious parallels with the development of computing, where in a couple of generations, you've seen early languages like COBOL and Fortran replaced by contemporary ones like JavaScript. Even though not many programmers moved from one to the other, it's just that new people came in with using the newer tools when they first learned. Well, nevertheless, I think even though people don't by and large change their theory and don't by and large change their programming language, it's still interesting to ask what makes a good theory and what makes a good programming language. So here is a classic answer, which was given by the philosopher Thomas Kuhn in 1977. He said a good theory has 5 properties. It has accuracy, so it should get the right answer. It has consistency, by which he really meant kind of self-consistency, but also that it played well with other bits of scientific technology, as it were. It has to have broadness, so it's not a theory about just a handful of cases. It has to be simple. It has to bring order to what is otherwise a complicated business. But it also has to be fruitful. It has to lead us to do new things that we otherwise might not have done. And when I look at that list, I'm struck by how relevant those are as criteria to describe a programming language as well. And I kind of think that if I ever were to try and develop a new programming language, its website might look a bit like this. It would say Kuhn, a language that's accurate, consistent, broad in scope, simple, and fruitful. Now, in practice, many programming languages are intentionally aiming at just 3 or 4 of these criteria and sacrificing the other ones. In Inform's case, we're certainly throwing out broad in scope. So Inform is not aspiring to be the software that you would write to, I don't know, coordinate bookings to some spa or something like that over a website. It's intended for narrative interactions. So we cross out broad in scope. It can, of course, be debated whether or not it's any of the other four, but it would certainly like to be. And the advocacy that I would do for Inform might try and play on those aspects of it, because I think those are the sort of most important considerations. Anyway, end of digression, and so much for this idea of a sort of elevator pitch advocacy for a language. If we move on to the next stage of getting people on board, well, how do we do that? We have to invite people to start using the tool. We always want that to be a sort of hands-on thing where people are actually themselves trying out the tool rather than simply being, simply having it described to them. And, as teachers, we're in the business of saying to our students, go on, have a go, give it a try. We know you've seen lots of software in your life, but this one will be fine. Just give it a go. And I think teachers and workshop leaders are crucial to this. I'm very conscious that there are people on this stream who know much more about this than I do. But I'll try to say what I think are the sort of two main principles of how to do this. So my first one is, I think it's important to go where the people go. So what I mean by that is this, and unless software is very simple, it's always going to have a whole landscape of possible use cases. Somewhere in the middle of that landscape, though, is a kind of capital city where most of the users are. It's really the intended uses in that sort of central area that the language was developed for. And that's where we should take our students, not to, perhaps intriguing outlying communities of people who are using it in unexpected ways. I think for Inform, that probably means trying to make a short and sweet narrative of some kind with a little bit of state involved, enough that some relationship between things or between people will change during the experience of play. And even if that relationship is as simple as the relation X is carrying an object Y or something like that. So a visit to a place, a meeting with a person, a historical moment perhaps, something like that. Many programming tutorials start, of course, with the famous program Hello World. I have to say that I find Hello World a little bit pernicious. Every language textbook since Koeniger and Ritchie in 1978 has begun with Hello World, but there's really no need for us to keep on perpetuating the style or expectations that existed then, today. And I have to say, I feel a bit the same about the interactive fiction equivalent, which is a story called Cloak of Darkness. This was a story which imposes a kind of 1980s idea of what the standard ingredients of an interactive fiction might be. And the idea is that you then show how this looks in different ways of making interactive fiction. But I think its very set of choices about what should be there and what shouldn't be there slightly distorts the language it's showing off. So to do Cloak of Darkness in Inform 7 would seem a rather retro sort of exercise to me, and maybe a bit off-center for what it really is or would like to be. Well, my second principle about getting people started is to do with metaphors. And I'd like to suggest that when teaching any tool, we have to kind of inhabit its conceptual world. And that means going along with its metaphors. So Photoshop can readily be used to edit 8x8 bitmaps if people really want to, but the writers didn't design it to work with individual pixels, even though it can. They designed it for photos. So they used metaphors like cropping and brushing, using a sponge, which I still don't really know what that is in real life, filtering and so on. And I think this strongly suggests to me that people who are teaching Photoshop should probably start by getting students to clean up an actual photo. The metaphors that software uses tend to be its organizing ideas, and that means that they tend to be its source of simplicity. And that idea of metaphor as a source of simplicity is certainly true of programming languages, which often claim to have simplicity by trying to put one big idea into our minds when we're using them. And for a lot of languages, this is the everything is an X sort of idea. So everything is a list, or everything is an object, or everything is a protocol, or something like that. Now, of course, the trouble with that is that users who are coming on from other experiences, perhaps having tried previous languages or just having naive ideas about programming, may not actually see it that way. And those users may simply want to imitate what they're already used to and simply to go against the grain of this new software they're using. I think that's been a big problem for the Swift language, for example, which didn't really articulate its message about how everything is a protocol strongly enough at first. So I think it's quite important for the early teaching of software and certainly of programming languages to try and stress what its big ideas are. Well, so for Inform, there are two big sort of everything is an X ideas, relations and rules. Now, the reason that there are two and not simply one is that it's in the nature of Inform that you start by sort of setting up a kind of a position in a simulated environment. But that exists without any sort of concept of time. And then you supply rules for how that develops in the course of sort of narrative play. And those are basically relations and rules. So these ideas are very much implicit in everything in the Inform language. So in the Inform language, you get declarative sentences like perhaps a ball is on the table. And it's perhaps not obvious, but what that's doing is establishing a relationship. So being on top of something is a relationship, and it's saying that there are these two things, the ball and the table, and that they exist in this relationship to each other. And then you also get paragraphs like, after taking the ball, say, oh, it's heavier than you thought. And that is an example of a rule. So although these ideas are always implicit in Inform, and in that sense, they're inescapable, I think it would be quite easy to teach Inform without ever really using these words. But I think it's quite a good idea to give students the abstract idea of what relations are and what rules are, and to encourage students to make new verbs of their own, even though the existing set is actually quite well stocked. As for metaphors, I was saying that Photoshop has the metaphor of, imagine you're in a photo studio working for a newspaper or something. Our metaphor with Inform is imagine you're writing a book. And oftentimes things, syntactically at least in Inform, look a bit as if they're already in a book. So the classic example of that would be the table data structure, which looks like something from a school textbook where a little table of data is being presented alongside the text. Well, so much for getting started. I'm now going to move to the sort of middle stage of my 5, but this is the one I'm going to say least about. This is the stage of self-guided learning. And this is perhaps where users have, enjoyed their early lessons or been to a workshop or something like that, and now they're getting to grips with the thing themselves. Perhaps they will even read the manual. Now, this is a stage which we put a lot of thought into in the early stages of Inform 7 in the early 2000s. I say we, Emily Short did a great deal of the work on this. We ended up with what at the time seemed like fairly radical ideas. The previous system that I'd worked on, which was called Inform 6 and is nothing like Inform 7, but that previous one had very much had a sort of book about it, which was what people did with languages in those days. They wrote books about their languages. And the book was one that you could actually buy. It's still available at Amazon today. But we didn't go that way with Inform 7. Instead, we had two sorts of documentation, two different books, which were intertwined and are full of links from one to the other. This slide shows that documentation inside the app. And inside the app is the point, because we didn't want a sort of separation where the software was on the computer, but the documentation for it was in a physical book in the real world. And we were trying to sort of blend the two together. Another thing that was mildly radical at the time, I think, was that we had this recipe book. It has 450 or so worked examples. And although we called them examples, and although in one sense they're sort of demonstration code, in another sense, they're really a large library of standard code that you can borrow from when you want certain kinds of things to appear in your story. Certainly, if you want to write a story which is all about gas diffusion or magnetism or building a set of encyclopedias or running an election or something, you can find all of that in this book somewhere. Well, a lot of the documentation that you're looking at here hasn't actually changed very much in the 2010s. Obviously, it's been sort of tweaked as new features have been added from time to time. But it may now be getting a little tired. And I would be interested to hear, particularly from educators, about that. It may be time to give it a bit of a revision. One loose end at present, I said earlier that we intentionally didn't go in the direction of making a printed volume. But it's a mild inconvenience that you can't buy the Inform documentation as a printed book today. And I'm increasingly thinking that we probably should make some sort of edition that you could buy in a cheap print-on-demand way at Amazon, if only, to be perfectly honest, to sort of claim the search term at Amazon.com, because I think people tend to look there when they're sort of trying to find documentation on languages. All the same, I think it's fair to say that the heroic days of the printed manual for software and all those sort of Addison Wesley books of the 1980s or the O'Reilly books of the 90s, I think those heroic days may be mostly behind us. Still, I think it might be useful to have a print edition, and I would welcome feedback on that. Well, so my next stage of engagement was the point at which people are starting to want to make their own improvements, little extensions to sort of share what they've done with others. And at this stage, they may not be necessarily doing things for their own use, or in fact, they may not be doing things for their own use at all. There are certainly some people who are really into Inform, but don't really want to write stories themselves. They're much more interested in sort of building out its infrastructure. Well, so in order for any stage like this to be possible, any kind of sharing and improving stage, the software necessarily has to provide features in order to enable that work. And this is where programs tend to grow software development kits or plugin architectures, or they provide app stores, or they invite third parties to write add-ons, that sort of a thing. So Inform does provide some of that in that it has a system of extensions. And these have been present in Inform since its very early days. The idea is that anybody can write an extension, and for the most part, that is just like any other sort of Inform writing. So in a sense, there aren't really any new skills to learn, although in practice, it takes a while to realize what would make a good extension and what is actually useful to people. So I think that's the upbeat, the sort of upside of the story of Inform extensions. The downside is that throughout the history of Inform 7, we've been wrestling with how best to make extensions discoverable, how best to make them manageable. And we've only partially succeeded in this, in my view. We've tried having a central repository at some times. We've tried not having a central repository at other times. It's quite hard to direct users to find what they want. Inevitably, perhaps, the world's of what's available is always going to be quite fragmented when it's a matter of individuals doing work, individually. But we can do better than we are doing, I think. There are also significant issues with how users are supposed to cope with dependencies, which is something one thinks of as a problem in more conventional software, but is just as much an issue for Inform. Large Inform projects might be using, let's say, 20 extensions of one kind or another. But once you're using 20 different extensions, it's quite easy to get into what you might call versioning hell, where you've always got the wrong version, or where your collaborator has got slightly different versions from you, so that it becomes quite hard for you to sort of swap versions of a project back and forth between you. So to that end, the new version of Inform, which I'm currently working on, includes a build manager, which is called InBuild. On this slide, it's doing some tricks at the command line, but the details of what it's doing on screen here really don't matter at all. So don't worry if this is illegible over Zoom or Twitch or YouTube or whatever. Now, I say that this is a new tool. What's really the case is that Inform has become a sort of hydra, in that it has three heads. There is a single compiler, but you can access the front half separately under the name InBuild. You can access the compiler as Inform, and you can access the backend, which I talked about a bit last year, as a tool called Inter, which deals with the sort of low-level code produced by the compiler. So although I'm talking about inbuild here, these are really abilities of Inform itself that I'm discussing. Anyway, so things that inbuild can do, it can identify what resource a file actually is. If you gave it an anonymously named object, it could try and work out what that was, what version it is of that, what that file would need in order to be useful. So for example, you can give it an extension and it will tell you what other extensions you would need in order to make use of that, and whether the versions are actually all compatible with each other and so on. You can point it at a project and say, are there any resources on my system that are missing that I would need in order to make that project work, and so on. Another useful thing is that inbuild can archive projects, in which it takes a snapshot copy of just those extensions which a particular project needs. So given that, you can then reliably email a project to somebody else and have it work the same at their end. So I mean, not a dramatic or exciting feature particularly, but that's typical of the kind of new features being added to Inform in this round, where I'm intentionally not changing the language very much, but trying to give it a much more modern infrastructure and much better facilities for different ways of working with it. So another example of that would be that, you know, back in 2005, the idea that new people going into programming for the first time, perhaps creative writers and so on, the idea that those people were going to be familiar with the source code control tools that existed in those days, that seemed just a bit too utopian. And even today, I think the idea that you would show somebody who's coming from the world of television, for example, and you say to them, well, you should be using Git to, you know, version control your screenplay. I think that's a bit of a stretch. But that said, it is much more common now for students in certainly university classes to be using GitHub for pretty much everything they do. And there are now quite a lot of tools which make that easier. It's nevertheless the case that Git is quite a hard tool to use, and that Inform projects are actually quite complex assemblages of files. It's actually quite fiddly to sit down and write an accurate .gitignore file for those who deal in the world of Git. It's quite hard to write an accurate file like this for an Inform project. And so the new version of Inform can just quietly do that for you. Another modest gain in usefulness is that multiple versions of the same extension can now exist side by side, which is very much a change on the assumptions made by early versions of Inform 7. So instead of just having one copy of the extension Locksmith by Emily Short, for example, you can now have multiple versions with different version numbers, which would be used as appropriate. Now, used as appropriate is, as you can imagine, a phrase which takes a bit of unraveling. We obviously want Inform to just, quotes, do the right thing, close quotes, but it can be difficult to work out what that right thing is. Nevertheless, the eventual goal here is that probably the best way we should collectively manage extensions is that people who are authors of extensions will post those as repositories at GitHub using a certain amount of semantic versioning. And eventually, inbuild will reach the point where it can simply download appropriate versions that it doesn't have from those repositories. And at that point, it will basically be a package manager. So I talked at NarraScope 1 last year about the need for a package manager. Inbuild is certainly not that program yet, but the infrastructure to make it is definitely coming into place. So underpinning all of this is that Inform is now following the semantic version numbering standard. And it does so in full, except that it allows a few shorthand forms, which doesn't change the sort of semantics of the semantic versioning, as it were, but does just make it easier to read. So you can just call something version 6. You don't have to call it version 6.0.0, for example. So for what it's worth, you know, if you have multiple copies of an extension, then Inform uses semantic versioning in order to choose the most recent compatible one for the project that you're working on, and so on. And for what it's worth, the mysterious collection of numbers and letters on this slide, that was the semantic version number for, as it happens, Tuesday's build of Inform when I took this slide. And for those old time Inform users, the traditional sort of number, letter, number code does still live on, but it lives on in the plus field, which any SEMSA fans will know is the not very meaningful bit. The next public build is going to be 10.1.0, and that dash alpha part shows that I'm currently sort of alpha testing this build, which is indeed the case. Now, something else that is enabled by inbuild is something which I've called basic Inform. This is a version of Inform stripped down to be a programming language which has no interactive fiction features at all. Now, that meant a quite significant change to the internal architecture of the Inform software. So in particular, it used to be the case that all Inform software included an extension called the standard rules, which basically set up the language and created all sorts of actions and did many good things. That has now been divided in half. One half is called basic Inform and just sets up the programming language. The other half is still called standard rules and does all of the rest. Something that is new in this nascent new version of Inform is the idea of a kit. A kit is a little like an extension, but instead of being written in Inform 7 source text and thus being a sort of high-level thing that anybody can write, kits are pre-compiled packages of low-level inter code. Now, that doesn't mean you can't create new ones. You actually quite simply can. They are, as I said at NarraScope 1, the notation for writing such code is Inform 6, even though it's not actually Inform 6 that you get, but that's another story. Inbuild incrementally compiles these as needed, so you can be working on these and everything will kind of just work, even if you're sort of tweaking at them as you work. Now, this is what Inbuild puts together for a typical story. So 3 extensions here and 4 kits. But when it's doing basic Inform, it collapses it down to just 2 extensions and 2 kits. All of the stuff involving command parsing, the familiar cycle of, you type something and the game replies, all of that goes, the whole world model disappears. You can no longer say things like the gymnasium is a room. Basic Inform doesn't know what a room is. It doesn't have a sense of geography. Now, all of that might seem like it's sort of Hamlet without the prince or sort of apple pie without the apple. The idea of this is not really so that people can write, tiny Inform programs to do, arbitrary computer science things. The idea is really that basic Inform is then a kind of kernel on which you can build other Inform-like languages if you want to. And I think it would be very interesting to extend it to other art domains. I've long thought that Inform might be an interesting way to present the facilities of the art language processing, for example, which makes sort of visual art. Well, just as a treat for those who, unlike me, I ranted about this earlier, for those who, unlike me, enjoy Hello World programs, this is Hello World in basic Inform. It compiled for the first time on the 6th of January 2020, which is fairly surprising for a programming language that was begun in the early 2000s. And it was one of the most technically difficult programs to get to compile that I've ever worked on. But we are now at the point where basic Inform projects are perfectly feasible. So I think that's what I want to say about extensions. So that completes the 4th of my 5 rungs on the ladder, and I'd like to move on now to the 5th. So this was the inside the box stage. This is the stage where people want to know how the software actually works on the inside, and perhaps initially they're just curious, but eventually some people want to be part of the crew, part of the inside loop. Now, obviously, that requires people to have access to the internals. The standard metaphor people use is that you can't work on the engine of a car if you can't open the hood. On the other hand, I have to say, in today's world, you can't work on the engine of a car anyway, because it's so opaque and complex and so full of sealed components that are difficult to do anything with. I look at this picture and I think, well, somebody there knows what they're doing, but it certainly isn't me. And I think that's the paradox of modern open source. Never have so many large programs been so openly readable as they are today. But their size and their complexity is just defeating. Their structure is often unexplained. They are full of unfathomable relationships which are implied by the code, but never explicitly written down. Now, many people love the aesthetics of mathematical abstraction when they look at software, which, it's a beauty cold and austere, as you might say. And, in some ways, the perfect way that this car engine interlocks and uses its space and so on is all very elegant. But somehow it's an aesthetic for people who are trying to verify the correctness of individual components, but it's not very easy to work out what's going on. So I want to go away from mathematics and borrow a standard tool from the social sciences instead. And the tool I want to borrow is the so-called thick description. So this is a term which is jointly attributed to Gilbert Ryle in the 1950s and to a man called Clifford Geertz in the 1970s. I should say I've never known how to pronounce the name Geertz. Broadly speaking, a thick description means that you describe not just the facts, what actually is the case, but also how people understand those facts or how they behave around them. So I'll give two very quick examples because this notion has been used in a very wide range of fields. A very influential group of archaeologists has for some years been excavating what is the world's oldest city. This is the Turkish city of Çatalhöyük, I think. I also don't know how to pronounce that. And it's about 10,000 years old. Now, these people do all of the photography and mapping and digging that you would expect archaeologists to do. But they also keep diaries about their own feelings as they do it. And they regard that also as part of the evidence that they're uncovering. I'm obviously oversimplifying, but a thick description of Çatalhöyük involves a certain amount of empathy, because it's not just, well, I found this statue over here. It's also, what was it like to live there? How did people here sort of, behave in relation to their rooms and their objects, which we still have? So at the other end of technology, my second example would be Diane Vaughan's classic sociological study of the decision to launch the Space Shuttle Challenger, a decision which, as you probably know, was ill-fated. There was a terrible accident as a result. Vaughan's study gives a thick description of the meetings ahead of the launch, when engineers were clearly worried, but they weren't quite sure why they were worried, and they went ahead anyway. And the result was that the shuttle was lost and that the astronauts aboard lost their lives. So those meetings were endlessly picked over afterwards. There were many, many books and newspaper accounts and congressional inquiries and so on. But most of those inquiries focused on the actual evidence, as it were. They wanted the facts. And the facts were things like slides, mostly that engineers showed each other, like the one that's on screen here. The trouble with that is a thin description. You can sort of see all the evidence that the engineers had at the time they made their decision. But what you can't know is how they thought about slides like this, what sort of culture they lived in, how they read between the lines, and so on. And what made Vaughan's study so effective is that she spent a lot of time just interviewing people in the industry about, well, what do slides like this do for you, and so on. And that is what a thick description is. So let's try and move that idea to the world of software. So as I've said, for me, simply posting the source code of a program is a thin description. A thick description needs all kinds of other material as well. That other material might be reasons why things are as they are, practical usage data, discussion of why some features added to the program were used a lot at one time, but now people don't seem to use them as much. why the default settings are the way they are. And for most of the world's big software, materials like that are quite hard to find, even if the source code itself is open. So you can find that kind of material sometimes in, there's a group called SIGPlan, in which the ACM collects history articles about how software was developed. There are mailing lists which are archived. Occasionally people go back and look at, well, how did people discuss this feature when it came in the 1990s or something. There are books like Bjarne Stroustrup's The Design and Evolution of C++, which is an excellent book, by the way, but which is now years out of date. I also don't know how to pronounce Bjarne Stroustrup, but I'm going to stop making that joke now. The trouble with these materials then is that they're not kept with the source code and they tend to fall out of date. So how can we get a thick description of a computer program and make it accessible to people and not have it fall out of date? Well, that requires an organizing tool, and one which binds the non-code and code materials closely together. So as I've suggested before, my belief is that literate programming is an ideal methodology for this. I'm not going to go into a lot of detail about literate programming because I talked about this quite a lot at NarraScope 1 and also in a lecture in London the year before, and those are both on the Inform website for anyone who's interested. But for now, it's enough to say Inform uses a literate programming tool called InWeb, and that presents a program both as something that can be compiled, but also as something that can be read. And it presents that in various different formats. It can be an ebook, for example, or something like that. But the primary one is it makes a website out of your program. So this on screen here is the contents page for the current version of a tool called InTest. Now, this is a not particularly interesting tool in itself. It's used for testing Inform. But what's, I think, interesting about this process is that it's not a single snapshot which is sort of done once. This is updated each time new code is checked into the program. So it's in that sense always up to date. It does contain the full source code for the program, but that's organized into chapters and sections with names that are legible to humans, and it's presented in a narrative sequence. It also contains documentation, command line help text, commentary about practical experience, and some advice on how to make changes if you want to add a particular kind of feature, that sort of thing. So, for example, the most important section in this code doesn't actually contain any code at all. It's just a section called How This Program Works. And it gives just a description of what the program does, but links into all of the functions which actually do the little steps being discussed. So again, you may not be able to read this page over Zoom or whatever, and it's fine if it looks fuzzy. The point is that these blue links, which you may be able to see in the middle of the text here, those click straight through to the functions of code that they talk about. And the literate programming tool, which makes all of this stuff, which, as I've said, is called InWeb, that tool automatically ensures that these links never break. Your program won't even compile if they do. So you're sort of forced to keep these reasonably accurate and up to date. Another example of a web containing, I should say web is the term used in literate programming for these things. Another example of a web containing material which isn't code as such is the performance metrics page from the Inform 7 web. And this does things like, for example, it shows that although there are something like 100 compilation stages in Inform altogether, only 9 of them take more than 1% of the compiler's running time. And that can save you a lot of time trying to work out whether it's worth speeding anything up. Similarly, it will show you how memory is used. It'll show you what proportion of memory is used. So, for example, 15% of memory is currently spent on holding the syntax tree in memory and so on. And I see those kind of usage statistics as also part of a thick description. And these, again, are automatically updated each time the test suite is run. I should show you some actual code, although I'm going to be very brief here because the code isn't really the point. So this is from just a small test thing just to show InWeb working on a tiny program. This is to do a traditional mathematical problem. But this is what code kind of looks like in this kind of heavily commented form. Similarly, and this is now not test code, this is in a sense the centermost paragraph of code right in the middle of Inform. It's the code that takes the subject and object of a sentence, joins them together with a verb, and constructs the whole thing as a proposition in predicate calculus. Well, I'm not going to say anything about how that works, but just to say this is the kind of thing that a web looks like when you burrow into it. Now, literate programming doesn't just have to be for currently live programs, ones that people are still writing on. It's also quite an interesting way to study old programs. If I can be autobiographical for a moment, in the early stages of the current lockdown, when my brother was recovering from COVID-19, we did a little work over Skype each evening, where we were working together on presenting a commentary for an existing program from a long time ago. So one of his hobbies is retro computing, and Toby Nelson, my brother, had disassembled and puzzled out the ROM for a 1981 computer called the BBC Micro. But the result was an enormous assembly language listing, and he wasn't sure how to present these findings. Well, literate programming turned out to be quite good at this, and what might have been just that big unreadable file has instead sort of turned into a kind of website of interlinked code, but it's got sort of downloads and photographs of the underside of the keyboard to try and explain why certain things in the ROM do what they do, and audio of getting an extra life in Zalaga to show the sort of thing that the sound chip does, and bits of historical documents and programs you can try out, and so on. So in a way, it's becoming like a sort of curated museum exhibition. And rather to my surprise, literate programming has turned out to be quite a good way to do that. At the same time, it's like a museum exhibition you can compile, because you can actually compile the results and assemble it into a correct BBC ROM image. So for example, InWeb lets you put things like, embedded YouTube videos into the middle of your, the commentary parts of your program. It lets you put, mathematical formulae. There are people who are writing scientific software who do need to justify every single step of what they're doing. And there's a little bit of that in the Inform webs as well. But for the most part, of course, what there is a really quite large amount of code. So I want to wind up by saying, well, roughly how far along am I with this whole project? So this is about where I've got to. While there is still work to do, I feel I am working on the finished article now and not kind of developing any new ideas or writing any new software from scratch. That was certainly not the case last year. The main publication is going to be this, as I'm calling it, a thick description, as it were, of a code base of about 300,000 lines. When it comes out, it'll probably be the largest literate program in the world. That probably says more about the unpopularity of literate programming than about me, but nevertheless. I now know exactly how I'm going to publish it. The tooling is all working fine. I work with drafts of the entire thing pretty much every day, and that was certainly not true last year when lots of these things were merely sort of imagined. The technical problems with the quite dramatically new lower level of Inform were still quite considerable last year, but now I think they're pretty well solved. So again, that was not the case at the time of NarraScope 1. So my intention, as I said last year, is to publish the new version of Inform as, I guess I'll call it a beta. It will be available alongside the existing one so that nobody gets stuck in kind of novelty hell where they have to use the new version, but the new version doesn't work for some reason. And I'm sorry that the whole business has taken me rather longer than I thought. But if you'll forgive me saying so, this is the thing about your life's work. It generally takes a little while to do. So I think with that, I'll stop, but I'm happy to answer any questions. I now am. Thank you very much. Yes, I'm sorry. Sorry, I was sort of waiting for you to speak, but yes, I now can. I have spoken. Somebody asked, have I spoken to Donald Knuth? The answer is I have, actually. He's a very nice guy. He came to dinner in my college once, so I kind of had the privilege of entertaining him. And his wife Jill, who is also an extremely interesting person. I'm one of the few people, many people in the world have got a signed copy of the tech manual, but I have a signed copy of tech, the program, and I rather like the idea that I have a signed copy of the computer program. In a way, I've been faithful to his kind of legacy in that I am doing literate programming at all. InWeb borrows quite a few ideas from the original Web, which was the program he wrote, and then its development CWeb. But it also diverges in quite a lot of important ways that probably reflect how we think about software now rather than then. And CWeb is fine for small test programs, but it really doesn't scale. I tried using it for about a year or so, but it just wasn't capable of dealing with really large programs. It's very reasonable to ask when I intend to post the GitHub repository, and the answer is obviously when it's finished. Finished, of course, is a strange word in this context because this is a living program. It's not a thing that's going to reach any final state until it's, well, I guess in some sense we all reach a final state eventually, but the idea is that it will continue to be modified once it goes up. Certainly before NarraScope 3, but with any luck, quite a lot before. I am working on what amounts to a draft version at the moment. I think experience suggests that I probably shouldn't give actual deadlines at this point. So the question there is I don't know if people can see all the questions, so I guess I should read these out. But the question there is, what implications do I expect InWeb will have for the use of Inform in educational settings? I think, oddly enough, it might have some use in educational settings, but not necessarily for Inform, because InWeb is actually quite a good way of showing a program and showing what it does. So something quite a lot of guidebooks to programming and so on have to do is they want to show you a sample program, but they want to tell you what each line means, so that they, in some sense, they want to reproduce the program, but kind of interrupt it with little sort of notes saying, well, this bit does this, and then, well, now we have to do such and such, and so on. And that looks rather like, if you're in the sort of literary critical world, that looks rather like a sort of close reading of a poem or something like that, where you quote a couple of lines from the poem, and then you say something about what's going on in the poet's mind, and then you quote another couple of lines, and so on. And InWeb is quite a good tool for presenting a computer program like that. So I could imagine it being used for teaching all kinds of software things, possibly. Certainly, I think it's quite a good way of putting an explanation of a program online, and that could be quite a useful thing in education. Whether it's useful as a way of teaching Inform, I don't know. That's an interesting question. Time will tell, I guess. I mean, its fundamental use is to, to make it possible to write large pieces of software rather than to demonstrate small ones. But